Okay, now we'll see the second of the packing rules. From the previous example, we have seen that we have used 5 bins, but they were pretty much underused. For example, in bin 1, we put item 2, and there was a leftover capacity of 8. In bin 2, we put item 5, which is this guy, so there was a news capacity which was 6. So we really didn't use properly the capacity of the bins, and this is what first fit is trying to do. The main idea is, instead of opening a new bin every time the current item doesn't fit the current open bin, let's see whether the previous open bins have some some residual capacity where we can make this current item fit. So differently from this next fit, we are not opening one bin at a time, but we are keeping open bins which were open before and which still have residual capacity. And every time we have a new item to be evaluated, we look at all the open bins and we check which one has a residual capacity which can accommodate the item that we are trying to match. So this is the base idea of the first fit. So let's see how we can develop the pseudocode for this first fit item. Okay, so again, the input is a given permutation, the weights of the item, then there is the capacity of the bins, which is all the same. Oh, weights is being repeated. Actually, this shouldn't be in weight. This should be RAM. See, I can write here. This should be RAM, because in this case, in this specific case, what we are having, we do not have only one bin which is open, for which we need to, it's the only bin for which we need to remember the residual capacity. We have several bins which are open. So this is a vector, is an array that keeps track of the residual capacity of all the open bins. So let's start with the algorithm. What do we have? Again, we have a variable b, which takes into account, in this case, is not the label of the bin that is open, but is actually the number of bins that are opened. And so in this case, we start with the b equal to 0. And we use the same thing. We need to scan all the item in the current permutation. At this point, we need to use another variable, and this is a Boolean variable, which is we call place, could be false and true. And place will indicate whether the current item that we are analyzing has been placed in one of the open bins. But let's see how the entire algorithm is. So we have two for loop, an external loop which scans the item and an internal loop which scans the open bins. So B is currently the number of bins which are open. So we want to check all of them. And what we want to do, we want to see if any of them can accommodate the item which we are analyzing. But let's see for a moment how this works when at the very first run. So we have k equal to 1. So we are analyzing the first item in the permutation, and we have we initialize every time we open a new item. At the beginning, this has not been placed, so the place is false. When b is equal to 0, we do not enter this for loop at all, because t goes from 1 to would go from 1 to 0, so we never enter this for loop. This is only valid when there is nothing open. So when b is equal to 0, we are analyzing the first item. We do not open this for loop, which I'm about to analyze in a moment, and we instead go to this line. In this case, this line says, if you were not able to put the current item in any bin, then open a new bin, update the capacity, I initialize the capacity of the initial bin, of this new open bin, which is of course full capacity at the beginning, assign the item to the new open bin, and update the capacity of the bin that where we located the item. So at the very first element, at the very first iteration, the very first item will be positioned in B1, because at the beginning B is 0. I do not enter this loop. I go into this if statement. B was 0, is now incremented to 1, so B becomes equal to 1, and I put the item over there. Then I go to the next item, to the next K. What happened when K is incremented? We analyze the second item in the permutation, and we initialize this Boolean variable to false. Now we check for all the open bins. Now there is at least one open bin, which is bin equal to 1. So we enter this loop. We enter this loop and we check, is the item fitting in one of these open bin. If it fits in one of these open bin, then I place the item in that bin, and then I exit this for loop. I do not need to go on again and see. This is what the break command over here it is. So this is the number of open bin, and I enter this loop as soon as B becomes at least 1. So if there are, for example, 3 open bins, I will analyze the first bin. If it doesn't fit on the first bin, then I exit this if. I do not enter this if. I go to the next bin over here, and then I will do the same for all the open bin. I will stop when the current item, the current bin that I'm analyzing, can have space for the item. So I enter this if statement. I put the item into the bin that has residual capacity. I update the residual capacity of that bin. And now I say this Boolean, I place the item in a bin. So I break. I do not go on. I do not go on the other. I do not analyze other bin. And I go directly to this if. I will not enter this if. Why? Because place is now set to true, and I go analyze the next item. So let's see how this work on our specific example. Again, we have the always 6 item, and we have again a permutation, and these are the weights. At the beginning, it's all initialization. There is nothing. Let's start with iteration number 1. We have, remember, 2 for loop now. So the first is on K, and the second one is on T. So when K is equal to 1, we analyze the first item, which is K equal to 1 is this guy. So we are analyzing item I, item I, which is 2, whose weight is 8. Now, I do not, B is equal to 0, so we do not enter this loop, and we go directly over here. So what we will do, we'll update the value of the bin. So we open bin 1, and we update the capacity of bin 1. So rem 1 means a residual capacity of bin 1, which is 2. And we have assigned bin 1 to item 2. Now, where are we? Now we are here. We have updated the residual capacity. We go on the next 4. So we go here. K is now equal to 2. Here you are. We are analyzing the second element, which is item 5, with capacity equal to 4. With weight equal to 4, because this is the item. What do? We enter the T loop. We enter the T loop, and now there is only one bin open, which is bin 1, whose residual capacity is 2. So we are checking with B. When B is equal to 1, we do not fit, the item doesn't fit because we need a capacity of at least 4. So what we do, we are here. This for loop is only valid for t equal from 1 to 1, so we are analyzing only one bin. We cannot, at the exit of this for loop, still the value of place is still false, so we go here and we open a new bin. And here you are, we open bin 2 and we place the item over there. Now we have two bins open, one with residual capacity 2 and one with residual capacity 6. Let's see what happened with the third item. So the third item, k is equal to 3, is item number 3, whose weight is 7. So if we look at the residual capacity of the two open bins, one is 6, the other one is 2. So we cannot fit in bin 1. We cannot fit in bin 2. We need to open a new item, a new bin. So we open a new bin. We assign the item to this new bin and we update the capacity of the bin, which initially was 10 and now becomes 3 because the item weight is 7. Let's go on the next item. Next item with k equal to 4. It's this guy here. Is item 6, whose weight is 2. Then we scan all the open bins. Remember, we have 3 open bins, 1, 2, and 3. Residual capacities 2, 6, and 3. Our item has weight 2, so it fits in the first bin. We place the item in that bin, so item 6 is in bin 1, and we exit the for loop and we go to the next item. The next item is item in position 5 in this permutation, which is this guy, is item number 4, whose capacity is 6. Now, the bin 1 is a residual capacity equal to 0, so it doesn't fit. Bin 2 has residual capacity equal to 6, which can fit this item. So we fit the item in bin 2. And then we exit the T loop and we go to the last item, which doesn't fit bin 1, doesn't fit bin 2, but can fit bin 3. And so we have the oh no, it doesn't fit bin 3, sorry, and so we need to open a new item, a new bin, which is bin 4, and we place the item in bin 4 and then we are done. Now what the solution is this one. We use only 4 bins with respect to the previous packing rule. We have obtained a better solution given the same permutation, and the solution is put item 2 and 6 in bin 1, 4 and 5 in bin 2, the third item in item number 3 in bin 3, and item number 1 in bin 4. So this is the first fit rule, which is an improvement with respect to the previous rule. Now let's look at the next rule.